All right, this is going to be 4 problems that I expect you to do and bring with you to class tomorrow. So I want all of these done when you come to class. These questions, once you can do these questions, you're done with the video. You can stop watching the video once you understand these questions. I'm actually going to make this one or equal to. Once you can do these, you are done watching the video. So once you feel like you can do this, you can stop watching the video. I don't want you to have to watch the videos all the way through if you're already good to go. Okay, so those are our questions. So we're talking about right now, we're going to be talking about 2.5 graphing linear inequalities. When you're graphing linear inequalities, you're actually showing the solution. So a lot of times I won't call this graphing, I'll just say solve. And when you're solving it, you're showing the graph. The graph is the solution, so that is the answer, okay? Graphing linear inequalities is very similar to graphing linear equations. So if this is my linear equation, I'm going to start at 3. I have a slope of 2, so I'm going to go up 1 over 2, and I'm going to connect it, okay? That means anything on this line is a correct answer to this equation right here. The difference is, when I say this, it's not just anything on this line, it's also anything above it. Anything above this line is also true. So to show that, we shade it in like this. And you guys have seen this a little bit in Algebra 1, so you kind of know what you're doing here, but we really need this shaded portion. If you're not shading it, then you're not showing me all of the solutions. You're just showing me a portion of the solutions, okay? So you need that. So 2 major things that we need to address is first, what these do, and second, what these do. So these guys right here, this means that the line is not included because it's not or equal to. So when the line is not included, we make a dashed line. So anytime I see a dashed line on an inequality, I'm thinking that the line is not included. So anything on the line is not a correct answer. When I see these guys right here, the line is included because it says or equals to, which means I make a solid line. And I know you guys did this in Algebra 1. So when I see a solid line, like in my example problem here, that means that the line is included. So this is a correct answer to that problem. This is a correct answer. This is a correct answer. This is a correct answer. This is a correct. All of those are correct answers. When it's a dashed line, if it was like this, that means that this is not a correct answer, but this is right next to it, below it, is a correct answer. And so what do I mean by a correct answer? What I mean is when I put that number in, it gives me a true statement. So let's take this one right here. This point is 0, 4. If I plug in 0, 4 to this inequality, it's going to give me a true statement. 4 is greater than or equal to 1/2 times 0 plus 3. 4 is greater than or equal to 3. That's true. So that means that this is a correct solution to this inequality. If you're not sure which way to shade when you're doing this, you can use that method to check. So if I'm looking at the inequality and it tells me y is less than 2x plus 1, graph it out, I go to 1, make a dot, go up 2 and over 1. I'm going to connect these. This one is not or equals to, so it's going to be dashed, right? So I got to make sure to dash it. Now if I'm not sure, I can pick any point that's not on the line. I'm going to pick this one right here, which is 0, 3, and I'm going to plug it in and see if it gives me a true statement. If it gives me a true statement, it needs to be shaded. So 3 is less than 2 times 0 plus 1. 3 is less than 0 plus 1. 3 is less than 1. That is not true. So this point is not a solution to that inequality, which means I'm going to shade the other direction from my line. So I'm shading down from the line in order to not get that point. Now some of you guys will be able to shade them real quickly and some of you won't. So it just depends on your abilities and your strengths. If they're not in the right form, which none of the examples I gave you were in the right form, you have to solve. So the same steps for solving for y that you've done before. So I'm going to subtract the 2x. and I'm going to divide by 3. Remember, when you divide by 3, you have to divide everything. It's not quite in the right form, so I'm going to reverse these. Now it's in the right form, so now I can graph it out. So I'm going to start at 2. I'm going to go up 2 and to the left 3 because it's negative. It says less than, it's not or equals to, so it's going to be a dashed line. And I can plug in a point if I want to, but I know that less than is going to shade this way. I just know that, okay? If you plug in a point, you'll come up with the right answer, okay? So if you want to plug in a point, here's a great point to plug in. It's pretty far away from the line. That point is -3 is 0. -3 times -2/3 is going to give you 2. 2 plus 2 is 4. So it's telling you 0 is less than 4, and that's true. So that point needs to be shaded. Hopefully that makes sense. Now, when we solved inequalities before, we were solving for one variable. You had to switch the inequality if you divided by a negative. Well, the same thing is true here. So if I have this, I'm going to subtract 2x. And then I'm going to divide by -3. So when you divide by -3, first, remember to do everything. But secondly, because we divided by a negative, this inequality turns around. And it's not quite in the right form, so I'm going to rewrite it 2/3 x minus 4. And then we can graph it out. So I'm going to start at -4. I'm going to go up 2 and over 3. It's not or equals to, so it's going to be dashed. And it tells me less than, so I'm going to shade like this. Now if I try a point that's not on there, let's say I try 3, -4. Should give me a true statement. -4 is less than 2/3 times 3 minus 4. -4 is less than 2 minus 4. -4 is less than -2. That's true. -4 is less than -2. So that point needs to be shaded, and it is. Let's say that I wanted to check it on my original problem just to make sure that I had the inequality the right direction. This point also has to work on your original problem. So 2 times 3 minus 3 times -4 is greater than 12. 2 times 3 is 6. -3 plus, or -3 times -4 is 12. So 18 is greater than 12. That's true. So this point, there's a way to test it on your original inequality rule as well. Okay, so I'm going to shade it in real nicely. That's it for graphing these guys out. So hopefully you're going to be able to do all of those problems. Remember, you're just solving for the y. You're trying to get the y by itself. Don't forget to do those 4 problems and bring them to me.